Okay, so for this video, I'm looking at the second feature of a river, and this feature is for deposition. And again, you can be asked to describe a feature of erosion or deposition, so we're choosing a delta. So to first of all start, I just want to go back over the methods of river transportation, how the material gets to the river mouth, which is where the delta forms. And just to remind yourself of this, traction, saltation, suspension, solution. These might be called dragged in your book, bounced, and then suspended as it is there. So dragged should be called traction. And this is where the heaviest material is rolled along the river bed. And this is usually in when the river is flooding, for example. So you'll have large boulders being transported and dragged along the riverbed. Saltation is where the pebbles and rocks sort of leapfrog each other, as it says there, sand-sized particles bounced along the riverbed. Not as much energy needed for that. Third is suspension. Your smaller particles, always getting smaller in size here, and the particles, silt and clay-sized, are carried within the water when there's turbulent flow. So that would, a lot of the times, the suspension and solution that would discolour the water. So you might have a brown colour, the Yangtze River, for example, the Yellow River, because of all the sand in it. And solution then, some minerals may be dissolved in the water. So you can't exactly see them. They might discolour it, but you can't see them. Okay, you'd need to, they're very, very, very small, microscopic sized particles. So all of this material is transported down, and just to be familiar with those terms which you would include in your answer if you're describing the formation of this to get you started. Transported down to the old age stage, and we're looking at the mouth of a river here. Again, maybe go back over the definitions of the mouth of the river versus the estuary. So that's the tidal part of the river mouth. So the example we're using is the Nile Delta. We'll look at that also in a moment. And the delta itself forms at the mouth of a river where the tide or longshore drift are not strong enough to carry away any deposition. So the material is being deposited here. The idea is the river is flowing into a slower moving body of water so that it slows down, the river itself slows down considerably, and therefore it doesn't have the same amount of energy to transport the material that it could have transported. So that material, because it's not being transported, sinks to the bottom of the riverbed and builds up in the river mouth. And it also just to note, it builds up where the longshore drift or the swash and the backwash of the waves coming in against the coast, that's the longshore drift. They don't drag the material out to sea. Okay, that's not occurring there, and the tide isn't dragging this material away. So in other words, it occurs at a low energy coastline. That's just a coastline, that what we would call that. So the river flows into the sea, it slows down, and as a result, it loses energy. The river deposits its load at this point, and the sediment builds up, okay, at the mouth of the river to form triangular shaped areas of land. So that's just simply where you can see the point there pointing back upstream, point going upstream, etc. There you go. So they're just triangular shapes, and they're pointing back upstream. The river then splits into distributary channels to enter the sea. So they're the distributaries there. There's 1, 2, 3, 4, 5, about 7, 6, 7, whatever it is. Okay, and seeds, etc., that which birds can deposit then knit into the soil and stitch that soil together, stabilizing them so they can be strengthened. So to withstand any storm waves that might want to crash against them during the winter time. So that's the formation of a delta. If you're looking at it on an Ordnance Survey map, there you can see your triangular shaped again, pointing back upriver. You may be asked to do that on your Ordnance Survey map section, but just to look at it as well also at the exact example that we were looking at, the Nile Delta. Here we are up at Cairo, and you can actually see the amount of towns and cities that are established in this area, and there is our Nile Delta. Okay, it's the whole shape itself is triangular, and then when you move in closer, you will actually also see the distributaries which we mentioned. You should be able to make them out there now. And there's another one. And there's more that go off in the different directions, but they're the two main ones as well there. Okay? So that's the formation of a delta. You can see just one other thing as well when we look at that. You can see the idea of the shape as it meets the sea of the coastline. This is the Mediterranean Sea that it's flowing into. So it's not a very stormy ocean. It's a small area relative to the Pacific and the Atlantic. So you wouldn't have massive wave surges crashing against the coastline. But here you've got any material which is being brought out into the Mediterranean Sea is being lapped straight back up against the coastline as the swash comes in or the waves come in, and then the backwash goes straight back out as well there. So one of those low energy coastlines where this is able to build up. And that's the formation of a river delta as a feature of river deposition.